Hey guys, good evening, all of you. Hey, good evening, Vinay. Okay, so guys, we have done with all the concept of the VTP, not VTP. We have done with the VTP modes, right? And we have done with the VTP summary packet and then subset advertisement. That's all. So subset advertisement, right? Then after that, we have another packet that is called as a, and this both the packet will send by the VTP server mode, right? Another packet we have something called as a advertisement request, right? Now try to understand what is the meaning of request packet. What is the meaning of request? Request means something like that. I don't have a complete information. Request is something like that. I don't have complete information, or something, or we can say that I don't have more updated information. So take example, right? Just take example. This is the switch over there, right? Switch one, and this is the switch two, and this is the switch three, right? So we have a link between this guy to this guy. This is a trunk link over there because all the VTP packet has to be encapsulated with the encapsulation protocol. It can be anything. Either you can use the 80.1q or either you can go for the ICEL, right? Okay, so this is my server, right? And this is my take exam server, and this is just a client, right? And right now, this guy, this is the link is down right now. Take example. Okay, we have a VLAN number 10, 20, and 30, right? And the VTP domain we have, same guy, same domain. They are all belong to the same domain right now. So VTP domain will be CCI. All good. Now, understand one thing. Right now, this link is down, right? So the same information VLAN number 10, 20 has on a switch 2 as well as, right? But not on the switch 3. Switch 3 is like a, we can say that this is the new brand new switches, right? This is the brand new switches. And I attached this switch into the VTP domain CCI, but this link is down right now. What happened once this link comes up? What happened? What happened? This link comes up. Once this link comes up, immediately what happened? The switch 3, right? It will send the advertisement request packet. Which packet? This packet. Now the client is informing to the switch to, hey, do you have a more updated information? Can you give me the more updated information? Because this guy does not have a more updated information, right? So switch 3 will inform to the switch to, hey, this is my advertisement request packet. Can you give me the more updated information? And now the switch 2 will give the subset advertisement and summary advertisement. And now this guy will maintain the same VLAN 10 and 20 information. So request is something like, I don't have a more updated information. Can you give me? And now they will give you. So have a look. Take example. VTP domain. I think so. I have to VTP. Clicking VTP operation. All good. So wait for some time. Meanwhile, because it takes some time to boot up the switches, right? Okay, I'll do one thing. Meanwhile, the password is the password. Interface gig 0/interface range gig 0/0 to 1 switch port trunk encapsulation .1q switch port mode trunk, right? And all good. And I'll configure this guys a BTP domain as well, right? BTP domain CCA. Switch one console, right? My my PC will become slow. Enable hosting switch three. Oh, switch three has 2 times. I need to take a switch two. This is the switch one, right? So let's define the host name of this guy. Enable configure host name will be switch one and switch two now, and you are two, right? Host name will be switch two. So let's copy and make the switch two as a trunk encapsulation.1q and VTP domain CC. So the switch two have defined this, so they will negotiate the VTP domain name, right, and the trunk as well as. So you can see the do show VTP status. Okay, why? You have to be there. Do show interface trunk. Do show VTP status. It's there, right? Take some time, and the switch three as well as. Do show VTP status. All good, perfect. What I'm going to do right now, MD5 checksum is mismatch on the trunk interface. Why? Something you are pre-configured? No, I don't think so. Everything's fine. You don't know to say everything is fine, right? Now perfect. So let's do one thing. I'll just gonna shut down this link, right? I'm just going to shut down this link. Okay. Start capture. Okay, come on. Start version. And what I'm going to do right now, let's me shut down this interface. Interface, what do we call gig 0/0. Shut it down, right? And yep. Okay, let's do one thing. I'll make this as a BTP mode client as well as, right? That will be good, I'll tell you the client will send the advertisement request packet, right? Normally what happens, server is sending the packet. So that looks cool, right? Git 0/0 shut down. And now let's come back to the switch one. I'll say the VLAN number 10, right? VLAN number 20 and VLAN number 30. So what happened after the three VLANs on the switch one? It's a VLAN number 10, 20, and 30. So this guy will say the information of this guy, right? VLAN number 10, 20, and 30. Okay, so you can see on our switch two as well as do show VLAN brief. Come on, do show VLAN brief. I do have information VLAN number 10 and 20, 30, right? Right now this interface is down, right? So does SOS3 has the updated information in the VLAN database table? No, they don't have, because this interface is down. Let's up this interface. Interface gig 0/0, no shutdown. How is the VTP packets are there? Dynamic trunk. DTP is going on by default. DTP is enabled. Not interested in DTP. Where's the VTP now? Let's make it social. Let's send it. Can you see that the advertisement request packet? And who is sending this packet? 0C08, right? SYS3. One of SYS3 and have a look. Do show interface trunk now. I do have a trunk. Do show interface gig 0/0 include VIA. Is it right? See MAC address. And he's sending the request packet. Hey, I'm the member of your your domain, right? Request means what? I'm just requesting to you. Do you have updated? Can you give me on? And I'm sending this request packet in the same domain because we are the same domain name, right? We are in the part of the same domain. And what happened? My neighboring switch is right. This guy, B401, is giving summary advertisement. At the same time, he's giving the subset advertisement packet. And that has the system is giving the VLAN information, right? This is a default VLAN, that's a VLAN number 1. We have a VLAN number 10 now, 20, and 30. So this is the use of advertisement request packet that is going to send by the, it can send by the server and client anyone, right? So he will just request, hey, I don't have the more updated information, can you give me? That's the meaning of request. I'm requesting to you. All good? Now, that's it about the advertisement request packet. I want to show you something else about the VTP now. VTP is something called as a roaming, not roaming. Start this guy. All good. We'll have 10, 10, 20, 10, 20, and 10, 20. Now, better to take a screenshot and then I'll, paste in the paint and then I can explain you. So requirement we have. Oh yeah, I know. This thing is. Okay. The system become a little slow. एक मिनट ना भाई. Now, the thing is that, can you see that we have a VLAN number 10 user and 20, 10 and 20 and 20 and 20 over there. So right now, this guy can send the traffic, right? If this guy send a broadcast packet, take example, I said the 1.255.255.255. What happened? All the VLAN number 10 user can listen this packet, right? Guys, try to understand. If this guy will send any broadcast packet, if this guy will send any broadcast packet in the own VLAN information and VLAN number 10, what happened? This VLAN number 10 packet will come to this guy and this guy as well as. So if this person will send the 1000 packet, right? And the packet size is almost, we can say that 2000 bytes. So this link will carry this packet, right? This trunk link. At the same time, this trunk link will carry this packet. And SYS2 has to process this packet, right? Encapsulation, decapsulation. Again, SYS3 has to do that. Encapsulation and decapsulation. And that is good, right? Because that's the behavior of the switches, right? This is good. because this is the behavior of the switches. You need to do the encapsulation and decapsulation. But take example, what happens if this user is not present? If this user is not present, what happened on this case? Again, if this guy is on the 1000 packet that has 200 bytes of packet, right? This guy will say receive the packet switch to. What switch to will do? It will broadcast the packet into VLAN number 10 at the same time on this trunk link as well as now tell me, do they have a VLAN number 10 user over there? No. Do they have a VLAN number 10 user? No. So it's a totally wastage of bandwidth, right? And wastage of resources. Understood? What's happening? Switch 2 has a VLAN number 10 user, right? Switch 2 can forward the packet into the VLAN number 10. At the same time, it will forward the packet on the trunk link. The reason is to forward the packet on the trunk link because on this trunk link, right, default mode is what? The default behavior. I can carry all the VLAN information from 1 to 4094. This is the behavior, right? The same behavior on the link as well as. The behavior is what? The trunk link carry all the VLAN information. Do they have a VLAN number 10 user over there? No. Then why should I forward the packet to this guy on this particular link? It's totally a wastage of the bandwidth and the wastage of the resources on the switch 3. They will drop the packet, of course, right? In that case, we do have one solution. What we can do over there, if you see the default behavior, okay, I'm not interested in this one, right? The client side, switch to switch 3 and switch 1 I'm interested in. Enable com terminal and host name. I want to define the switch 1. Switch 3 we have same thing. Host name switch 3. Service switch 2. Okay, switch 3. And enable com terminal and host name we have switch 2, right? And all done. Beautiful. And let me copy this same command. Okay, because I need to make the same domain name, right? So I need to do this one. And oh, mistake. That should be gig zeros last 3, right? Not the 2. CC, that's not a big deal. And what I can do over there, I see the interface gig zeros last 1. Switch port access VLAN number 10. Switch port mode access. Interface gig zeros last 3. Switch port. Trunk encapsulation dot one q. Switch port mode. All good. And now hope they will form the trunk, and let's define the the interface mode. The interface gig 0 slash 0 is the VLAN number 10 and gig 0 slash 1 is the VLAN number 20. Interface gig 0 slash 0. 20, right? Copy. Switch 1, sorry. And come on, please. Don't give me the users. And here we have done on the switch 1. And this is same thing on the switch 2. So It's 0 slash gig 0 slash 1 and gig 0 slash 2, right? So gig 0 slash 1 this guy and gig 0 slash 2 this guy. Copy. One is a VLAN over 10 and 2 is a perfect same one. Nothing's difference. Uh-oh. Yep. And here we have done. So if you now verify on a switch 2, we do have a trunk, right? On both the interfaces, gig 0 slash 0 and 3. And the if you see this part, I want to show you. All the VLANs is by default allowed. All the VLAN is by default allowed. Now tell me, does this guy has a VLAN number 10 over there on a switch 3? No. So why should I allow the VLAN number 10 over there? If the VLAN number 10 is not allowed on this interface, can this person will send the broadcast traffic on this interface? No. Right. If the VLAN number 10 is not allowed on this particular interface, can the switch 2 will send the traffic to the switch 3? No. So in that case, what happened? I can see the bandwidth of this particular ring and see the resources of the device, this device as well as. Yeah, because there's no VLAN number 10. Why should I send a broadcast packet to this particular interface? So I just need to go on the switch 2. And what I want to do, tell this person, hey, listen. My laptop is a bit slow today. I don't know why. Interface gig 0 slash 3. Switch port, trunk, allow, VLAN. I'm going to remove, right? Which one? VLAN number 10, because VLAN number 10 is not present on a switch 3 side. All done. So now if you see the output do show interface trunk, what happened? Can you see that? On this particular interface, all VLAN is allowed, but on this particular interface, no VLAN is allowed. On switch 3 as well as, see, I'm going to allow the every VLAN, right? Because manually I have configured on this side, right? That's why it's not impacting on this side. So on switch 2, what happened? I manually configure, hey, you're not going to allow the VLAN number 10. So can I send the traffic to this guy now, between this guy to this guy? Of course not. No possible. This is how we can save the bandwidth, right? And save the resources of the device as well as. But again, this is the static way to remove VLAN from the interface, from the trunk interface. We can say the manual. Manual is you are going to do. But after what happened? Take example. Take example. What happened? After that, this PC will be added, right? Take example. Then if this PC will be added, then what happened? Again, you need to go on the interface switch 2, and what we have to do? We need to say that, hey, allow the VLAN. Switch 4 trunk, allow VLAN, add. We're going to add the 10, right? Do so interface trunk now. Done. Previously I removed, now it allow. Again, after that, what happened? If this guy will remove, they take example, right? Then again, you need to go on the particular interface switch 2 and say, hey, listen, there's no VLAN number 10 is on a switch 3. Do one thing, remove it. Because I can save the wastage of bandwidth and resources as well as, right? So I'm just going to go on the interface 0 slash 3 and say that, hey, remove this guy. And now all done. It's removed. But again, after that, it comes sometime later, maybe the 1 hour. Then again, you have to go and add this particular VLAN where, I said, okay, let me add it. Interface gig 0/3. And I will add this guy, right? Put the add keyword. And all done. Do so interface strong. All done. I'm going to allow. But again, this thing you have to do the manually. This thing you have to do the manually. So you have to keep monitoring like a static route. In a static route, we have to manually define the path, right? Okay, I want to go this side, 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 I want to go this side. Manually, you need to define the path. That's not really the good solution, right? So in that case, we have I cannot say that this is not a good solution. It's depend on the requirement, right? So another dynamic way we have that is called as a VTP domain. Sorry, VTP pruning. By default, VTP pruning is disabled, and you cannot enable VTP pruning on client and transparent switch. Once you enable on server side, then server will reflect the VTP pruning configuration on client and transparent switch. So if you have a VTP, server or client, if you see over there, I'll do one thing. I'll go now switch one, and I say that, hey, first of all, by default, the VTP pruning is disabled. If you see, do show VTP status. Right? And my mode is server right now. I can make this guy as a VTP mode as what client. Just want to show you, right? You cannot enable the VTP pruning in the server client mode. VTP pruning. You can't. I need to have it in the server mode only. Even if I'm going to define the VTP ticket transparent, mode transparent. A little bit. And I say the VTP pruning again, same command. It will say, hey, I cannot enable the VTP pruning until unless in the VTP server mode is not there. So I have to make sure that, right, VTP mode will be server. And what I'm going to do now on a switch 2, I'm going to make this guy as a VTP mode transparent. Okay. Or you can make it client as well as on a switch 3. I'll make this guy as a client. Now see the beauty. So this is the server now. This is transparent. And this is the client. If I'm going to enable the VTP pruning on the server side, right? VTP pruning. And now see the do show VTP status, right? You can see that. Enable. And it reflects the information to the client. And okay, it's not reflecting on the server side. Or just transparent. Okay, transparent is local to the switch, right? Yeah, it will not save because they are not participating in the clients. It will just say the client, not the transparent, because transparent is local to the device, right? Now, if you have, look, let's do one thing. Let me make this guy the client as well now. VTP mode client. VTP mode client. Now all good. So do see VDP status. Come on. So now it's enabled. I haven't enabled this thing, right? I just enabled on the server side, and this guy has enabled on the client as well as. Now, if you have a look, if you go on switch to and say that do show interface trunk now, can you see that all this information is for the VLAN number 10? Sorry, all the information is along in the gig 0/0 and 3 as well as. VLANs in the spanning tree forwarding state that is not pruned. It means that this information, what is the meaning of prune first of all? Prune means what? Stop. The meaning of prune, right? If you just Google it, the meaning of prune is just saying that, hey, stop sharing the information. That's the meaning of prune. And which packet I'm going to use? I will use the join and prune packet. Both are the same packet. So what happened? Take example, if the switch 3 does not have a VLAN number 10, for example, they don't right now they have a VLAN number 10 and 20, right? This guy also have a 10 and 20, switch 2, and switch 1 also have 10 and 20, right? So if you see on a switch 3 side, okay, let me take a Wireshark. What switch 3 is going to inform to the switch 2, hey, this is my active VLAN information. This is my active VLAN information I have. Wait for some packet. Join message. Can you see that? What is the MAC address of the switch 3? So switch 3 MAC address, do show interface, gig 0/0 include VIA, and the MAC address of this guy 0C63, right? And have look the 0C63. I think so. This one is your yes join message. You can see that what switch 3 is sending. He's sending the BTP join and prune message, and what he's telling this person, hey, this is my active VLANs. One more thing, you cannot prune native VLAN. That's a VLAN number 1. The reason is that the native VLAN information carry the control plane packets. That's why you cannot prune the native VLAN. So what switch 3 is saying that, hey, this is my active VLANs, and this is my active VLANs. And that's why what switch 2 is saying that, switch 3 is informing this information, right? This is my active VLANs. Can you see the same MAC address? So switch 3 is telling to the switch 2, hey, this is my active VLAN. So what switch 2 is doing? Switch 2 is putting this information into the forwarding state. Right? Have a look. Such the book was there, so simply switching, right? My bit slow laptop. So simply write and switch. Yeah, this is okay. They have a pruning. So have a look. The BTP ensured that all the switches in the BTP domain are aware of all VLANs. Guys, read that again. BTP ensured that all the switches in the BTP domain are aware of all VLANs. However, there are occasions when a BTP can create unnecessary traffic. All unknown unicast and broadcasts in the VLAN are flooded in VLAN, are flooded over the entire VLAN. Entire VLAN is all the switches. For example, 1 to 100 switches, if you have a VLAN number 10, 10, 10, 10, this information will be flooded to the every person. All the switches in the network receive the broadcast traffic, even in the situation in which few users are connected in the that VLAN. BTP pruning is a feature that you use in the order to eliminate or prune the unnecessary traffic. So the main reason to use the BTP pruning, we need to remove the unnecessary, the flooding traffic. Understood? Now have a look. When a BTP pruning is enabled on the BTP server, pruning is enabled for the entire management domain. Your domain name, BTP domain name, making VLAN prunings eligible for the pruning ineligible affect the pruning eligibility for those VLANs on a trunk only domain. Only for the that trunk interfaces, right? Not for the complete domain. Pruning makes effect several seconds after you enable it. BTP pruning does not prune the traffic from the VLAN that are pruning ineligible. That is called as a VLAN number 1. That's a native VLAN. And this in 102 to 105. This is a reserve for the FDI tokening and different use for, right? Traffic from this VLAN cannot be pruned. So by implementing the pruning, we are just going to remove the unnecessary flooding over there. How? Have a look. What I can do right now. Right now, if you see the Swiss 3 is advertising the active VLAN information. And what are the active VLAN information we have? 10 and 20. Don't consider this, guys. This is the native VLAN we have. So I'm not going to consider, you cannot prune the native VLAN. You cannot prune the native VLAN. I'm just going to consider the VLAN number 10 and 20. Now, what I'm going to do on a Swiss 3, I'm going to remove this guy. I said, hey, no VLAN number 10 now. Okay, you are in the client mode, so you cannot delete it. So make it server. And I said, no VLAN number 10. So do so VLAN brief now. And wait for some, so I don't have a VLAN number 10. So wait for some time. And I'll look for the 063 now. See, I'm not advertising the VLAN number 10. So now if you go back to the Swiss 2 and check this information, hey, previously all this information was present. Now do so. Okay, interface trunk. What happened? So I'm only advertising the active VLAN information. Can you see that? Again, after that, if the VLAN comes up, take example. Okay, I'll add the VLAN number 10. Now I have a VLAN number 10 over there. And the ports are belong to the VLAN number 10. Now if you see, it will advertise the join 10 and 20. Wait for some time, because if you read this part, he's saying that it takes some time. Pruning, video pruning takes effect several seconds after you enable it, right? So you have to wait for some time. Okay, now 063. Come on. Still not. Still not. If you do on the real device, right, it's do the fastly as compared to the GNS3, right? Okay, give it now. Meanwhile, I'll do one thing. I'll open the window because I need to show the different practicals. So I can open the window. And Till that time, it will show you the magic. Magic takes some time. तुम आए तो आया मुझे नहीं फुटबॉल चल रहा है खेलोगे हाँ, तुम डबल मास्क लगा के आए हो नहीं होगा कोविड रहते मैं नया लाया पिछले साल से यूज कर तो पिछले साल से यूज कर तो पिछले साल से यूज कर पागल है क्या तुम यार इंटरव्यू थोड़ा भी I knew that. Huh? I knew that. Okay, don't say anything. Mic is on. भेजा कैसे नहीं अभी तक? Okay, let me see. What's sending? Man, come on. Basi, sending. So it takes some time. So you need to have a good patience whenever you're doing the practice on the, the virtually, right? It do the real acts is good, but virtually you have to have a patience. So this is all about the guys VTP pruning. Now, if you see on a switch to now, previously this information was not there 10, and here we have to go. Bingo. So make sure that you cannot prune the native VLAN, the VLAN number 1. You cannot prune it. Now tell me, I have a quick question to all of you. Which one is better? VTP pruning is better, or switch port trunk allowed VLAN is better? Good enough. Mohito something is better. एक और बहुत अच्छा है. True, both. Hey guys, see, it's depend on the requirement, right? It's depend on the requirement. Like, you know, if you do the prune is a dynamic way. They will remove from all the interfaces, right? If this about this interface as well as. Okay, so even this guy cannot send the traffic. So trunk allowed is better. Manual is better in this case. But again, it depends on the situation. If you this guy also don't have a VLAN number 10, do it the pruning. Hello. I know you are in the Ladakh. Can you give me some time? I'll call you back, okay? Half an hour. Oh, okay, okay. Okay. So it's depend, right? You cannot say that this is good, this is bad. It's depend. Okay. Now, next point. Okay. You started now. It's a little slow today. I'll stop this guy because it's Wi-Fi का नाम है मधु कुमार. Yeah. Same password है. बताइए क्या? Okay. It's 98865 42425. Cool. So now we have to go a little bit down, and here we have. Now let me reduce the putty size. Okay. appearance change, and I think so 9 is better for this one. Your 10 will become very small, and that's good. Start with my devices, and here we have. So diagram, and let me take a screenshot and put it in the. And here we have, right? Okay, so guys, let you know the IP address of this person. This guy's IP address will be 1.1.1.1. This guy's IP address will be 1.1.2. This guy's IP address will be 1.1.3. This guy's IP address will be 1.1.6, right? All good. And over there we have a trunk link, and right now they all belong to VLAN number 1. No issue. The condition is what? Take example, this is the PCA. You can assume this is the PC, right? It's not a router, it's a PCA, the PCB, and PCC and PCD. What I want, this guy should not communicate with the A should not. You can assume like a server as well as you have to just, assume the scenarios as okay. So A should not communicate with B, but A can communicate with C. How? What will be your approach, right? What will be your approach in this case? You can have a like law. Can we do the ACL over there, something like this? Maybe that's all you have idea, right? In the CCNA that you have learned this part, right? Okay, law. Let's do one thing. Let's apply the ACL and deny the traffic and the permitted traffic, right? I'm not telling you that your thinking is good, very good. But the thing is that ACL will require the lots of the command over there. By default, if you have a look, by default, if I go to the switch router number 1, that's this guy, right? They can communicate with the all this person, right? Ping 101.2, done, and ping 103. I do have a communication, right? What I want A should not communicate with the B, and A can communicate with the C. In that case, what happened? I'm just going to use the feature that is called as a protected port. By default, all the switch port interface is behave like unprotected. And that's why they have a communication, right? If you have a look, go on a switch 1 and see the configuration of this part. So interface, no interface each 0/0 switch port false. With the same thing, if you have to look for the 0/1 as well as include protected false. Switch 2 now. Sorry, interface 0/2 done. 0/0 done. All they have false. And that's why they are able to communicate. That's why they are able to communicate. What I'm going to do, I'm going to make on a 0/2 0/1 interface, 0/1 switch port protected, right? Now, if you have a look, Go on a PC number 1, ping, it's working. Yeah. Make that layer. Let me recap. Let's forget. What I now? This is not protected, and but this can 1.3 will. Yep. So now what I did over there, I just make this two interface as a protected 0/0 and 1, 1 and 0. So in this case, what happened? This is the interface right now is a protected. This guy is VLI protected. This guy is VLI protected. So protected and protected port cannot communicate. I'm going to get that. It's going to protected port. Result will be what? No communication. Are protected. They do have a communication. So that's why PCA can communicate with the C, but A cannot communicate with the B. In this case, what happened? Ports are local to the switch, right? If I'm going to make this guys are protected, what do you think? Will they communicate from here to here? Yep. Will they communicate? PCA to the this guy 101 to the 106? Yep, it's not because ports are local to the switch. So if you go to the switch 2 and make this guy, right? And now if you see I make this guy as a protected port, if I'm going to ping from the PC1, it will ping the 106 as well as. Because ports are local to the switch. Ports are local to the switch. That's why they are able to communicate. Guys, anyone has questions in the protected port? Very simple commands are there. Just write on the commands so you know you can. Okay. Yeah, Javed, do you have questions? Yeah, please ask me. You can open your mic. I think so. Mic is open. Okay, 1 minute. No, you can open it. Tell me what happened. It's on now.
Yes. Hi, sir. How are you doing?
I'm super cool, man. How are you?
Sir, I'm back, sir. I was busy on some tasks. So from today, I will be on your class, sir. This class.
How? Good. Any questions, David?
Yes, sir. The video. How can I find this video, sir?
Oh, you want a video? I will say that video. Don't worry. I'll say
Thank you,
that.
sir.
All good. Now let's come back to the different model. This is done. Little bit funny. Back. Same scenarios is there, right? But instead of doing the the protected port, now we have something is different, because protected port is not so scalable, right? It's a local to the interface. It's not so scalable. Same one, we have a IP will be this guy will be 102, and this guy will 103. Same scenarios, right? What I want, copy the same one. A should not communicate with the B, but A can communicate with the C. No communication between this guy and this guy, but we do have a communication between this guy to this guy. Here I'm not going to use the protected, because protected port, what happens, the local to the switch. So another way we have a concept is called as a VACL. VACL, if you just split this word, we have something called this one. So V4 VLAN, ACL4 access list, VLAN access list. V4 VLAN, ACL access control list. That's you learn in the CCNA part. The same concept is there. But the thing is that in your CCNA that you have learned how to apply the ACL on a particular interface, right? But here we are going to apply the ACL on a VLAN. That's why we are going to call this guy as a VACL. And that on a router, you are going to apply the ACL that is called as the IP ACL, right? Remember this command IP access list, you are putting the command like this. IP means what? It's on layer 3. And VLAN means what? It's a layer 2. It's a layer 3. This keyword is going to represent it's a layer 3. This keyword is going to represent that it's a layer 2. So I'm doing the filtering based on the layer 3. I'm doing the filtering based on the layer 2. So what we have to do over there, first of all, let me show you this one. Switch 1. And okay. Yes. Router 1. Router no 2. 3. If you have a look, all they have a communication right now, all they have a connectivity. So I can ping from the PC number 1. 1 or 2. Come on. Take some time because switch is getting on. All good, it's done, right? And 1 3. I have a communication from that room, router 1 to router 2 and router 3. What I'm going to do now on a switch 1 with a VACL, right? To implement the VACL, we have 3 steps. Step 1. First of all, right, take example of this one. Whenever you go to the shopping mall, right, and take example, you just have a 2,000 rupees, and what happened? You need to purchase some t-shirt. So guys, you are the living things. You do have a capability. You do have an ability to select. Okay, this t-shirt looks cool on me. That is called as a selection, right? But how does switch will make a selection? Hey, this route is good. This route is bad. This packet is good. This packet is bad. So whenever the selection comes in the networking, always we are going to use the access list. In layer 3, we have something called as a access list as well as or prefix list as well as. But in the layer 2, whenever the selection comes in the picture, you are doing the access list, or either you can use the MAC ACL as well. As ACL is used to do the packet filtering, right? At the same time, ACL is also used to match the particular route, or we can call it interested route. So based on the ACL, it's not like that we are always doing the packet filtering. Based on the ACL, we are making a route selection. Based on the ACL, we are making a route selection. Okay, this route is good. This IP is good. This IP is bad. So I'm going to do the ACL, and I'll say the access list on rate. I say the permit. I'm allowing this guy, hey, whenever the PC 101 wants to communicate with the 102, allow it. And step number 2, now come to the same scenario, right? Once you have done with the selection of the the t-shirts, after that what happened? You reach to the billing counter, and the manager is saying that, hey, the price is 2,200 rupees. How much money you have? 2,000. What is the next thing we have to do? We need to do the bargaining, right? We need to do the bargaining, because I just have 2,000 rupees and now the total price is 2,200. So what I'm going to do, I need to do the bargaining, right? Hey, can you give me this all this t-shirt in the 2,000 rupees? So what you are doing over there, you are just modifying the price. You are just modifying the price. So same thing, whenever the modification comes in the picture, in the layer 3, we are going to do the route map. In the layer 2, we are going to do the access map. Access means what? Layer 2. So I said the VLAN access map and define the name of the access map, because you can have a multiple access map on the switches, multiple access map. And here I'm going to define the action as the match IP address. The IP address means what? ACL number 100 that I've created over there, right? And here I'm going to define, hey, whatever the route is present, whatever the IP address is present in the match IP address 100, set the action drop. So we have two types of clause over there. This is called as a clause, match clause and set clause. Either we have a match clause, either we have a set clause. In a match clause, what happened? We are matching the particular route. We are matching the particular IP. We are matching the particular interface. We are matching the packet size. We are matching the toss value. We are matching the cost value. Many things you can match it over there. Many unlimited things. Use the complete networking is depend on the this guy and this guy. The policy section, if I talk about, right, the complete policy, the route filtering, manipulations, redistribution, every concept is done on this two guys. So you can match the unlimited things, right? Lots of, not weekends, the unlimited, lots of things are there. And here set means what? We are going to define the action. Action will be what? It's drop, because I want to drop the packet. A should not communicate with the B. A should, I'm going to allow this person, and in the VLAN access map, I'm going to call this guy and say, hey, whenever the traffic is going from 101 to the 102, let them drop. But like ACL, we have implicit deny. In the VLAN access map, we also have an implicit deny. So otherwise, what happened if I'm going to put the exit over there, and if I'm just going to apply this command, what happened? The A also cannot communicate with the C. So in that case, we need to say the VLAN access map CCI, right? Okay, I'll do the one configuration in the, no, that will be good because I don't have a space. Let's come to this guy. I say that access list on rate commit ICMP host will be 101, host will be 102. Because 101 cannot communicate with the 102, right? This guy should not communicate. And the VLAN access map, define the name of this guy, CCI, define the sequence number, right? If you want, by default, it will take the 10. And here is the match IP address on rate. You can see we can match IP, IPv6, or MAC as well as. If you put IP, then you have an address. What address is in there? He match the access control list. And access control list number is what? 100. And here I'm going to define the set action. Okay, command. Action, not the set is not keyword. Is action will be what? As a drop. And the remaining packet, right? The VLAN access map, same number CCI, commit 20. Action will be forwarded for the remaining traffic. So A can communicate with the sheep. And here we have, you see that the VLAN number 10, IP address 100. In the IP address 100, what happened? We have this guy, 101, 102. The action should be drop 20. Action will be forward for the remaining traffic. And then here I'm going to apply this guy where I said the VLAN filter list. I want to filter the traffic. What is the name of VLAN? CCI, the map, this guy. And where I'm going to apply in the VLAN list to number 1. If you have a multiple VLAN, you can apply to the multiple VLAN as well as, for example, you have inter VLAN routing and you want to filter this guy, you can do that. You can map, you can put the comma and you can apply the different VLAN, VLAN 10, 20, and anything. Right now, all the ports are belong to the VLAN number 1. That's why I say the VLAN number 1. And then this is the last command. Apply it. So here we have sequence number 20. Here we have a sequence number 10 because 10 will should be forwarded. And always the scanning will be done from the lower sequence number to the higher sequence number, like ACL. In ACL also, what happened? The scanning, right, will be start from the top to bottom. So top to bottom. Right, just to do this method. And here the action will be what? Forwarded. Right. So whatever the packet that is coming with the source IP address, this guy, destination will be this guy, match over there 100, and action will be drop. Remaining traffic forward. And after that, I'm going to apply into the VLAN access list. This is the step number 1, 2, and 3. And now see the magic. 1 or 3, I should be able to communicate. 1 or 2, not. All good? So this is a verification command. You can verify, show access list. That updated over. 5 matches is having, 5 packets are sent. All the 5 packets has matched. All clear. Any questions? So see the configuration and let me know. Again, if you want to do the, like, depend on the field of which VLAN you have to define that that's VLAN owner, right? It's not like that you are going to define the only one. It's depend on the which VLAN you have. Foreign interview, foreign interview, Indian. ज्यादा इंडिया की बात है ये इंडिया का तो नहीं है तो किसको भेजा था लिंक मेरे पास दिन भर में काम क्या होता कुछ तो मैं इसी पर और पहले पता क्या है लाइक प्लेटफॉर्म है तो वो एक प्लेटफॉर्म भी है तो मिलता है क्या मुझे चारों से टेस्ट कर सकते हैं